Hi again, let's solve one last problem using Euler's equations. Consider that you are on the surface of the Earth, which I guess it is easy to imagine. Now assume that you want to travel from a higher arbitrary position to an arbitrary lower position. The only thing that you have to do this motion is gravity. Let me choose this axis as x going down and y going to the right this time. Because of gravity, you know that your velocity will be the square root of 2gx. You want to minimize your time of travel, so you write the differential of the displacement, ds, as, and then you solve for time t, where the velocity is the square root of 2gx. As usual, you divide by the x, so that x will be your parameter, y will be the quantity that depends on x, and y prime will be the derivative of the quantity y with respect to the parameter x. So now the function f is this square root. Now you apply Euler's equations and find that the derivative of f with respect to y prime is constant. Just let me call this constant as 1 over the square root of 2a, where a is another constant. We can actually derive f with respect to y prime. Solve for y prime and integrate it. If we do a change of variables where x is equals to a times 1 minus cosine of theta, so dx is equals to a sine of theta d theta, the integral becomes, and the solution of this is. So this result together with the change of variables is, which happens to be the parametric equation of a cycloid. This can be drawn, this trajectory, by the trajectory of a point on a wheel that moves along a horizontal line. If you ever want to design a roller coaster, you might want to consider these trajectories to minimize the time and maximize the fun. May the science be with you.